This video covers the setup and operation of the HolidayCoro 951-77 Long Range Smart 16 version 2. This will be with xLights. See our other videos if you're not using xLights and using an application that requires configuration of the receiver via the controller. This receiver is identified by the fact that it has a screen on it, and this current receiver has no configuration. I'm going to go to the left side, press the test button, the blue light will come on, and we can see no config is present right here. Now, we do have some light hooked up. We have some seed pixels. Those are going to be hooked up to output 2, and on output 9, we have some traditional pixel nodes. Now, let's go ahead and show you what else is configured in this setup that we're showing you. So the first thing is, let's look at the controller. So the controller is, and let me pull this off, this box right here. This is a HolidayPix Pro version 2, and this would not matter if it was a version 1, 2, or 3. These all apply the same. In this particular case, we have a 16 SPI output board and a long range board. Now, I am going to be referring to the jacks as jack 1, 2, 3, 4. It's important to understand that these jacks each correspond with 4 ports of output on the controller itself, and we'll show you that in xLights. Now, also in here, we have the cable going, as you can see, through this input, and it goes up, over, and into the board. So you can see that here. You can see that this board is connected right here, and that is the line in. Now, we are not going to cover daisy chaining these receivers at this time, but it is possible to daisy chain these receivers. Now, when I say daisy chaining them, it's important to understand that this board has receivers A, B, C, D, or it has four output receivers per board. So this particular receiver acts as if it is 4 independent boards. Now, you can also look to see that these are labeled 1, 2, 3, 4 for receiver A, 5, 6, 7, 8 for receiver B, and so on. So consider these as individual receivers from the concept of xLights, and we will be configuring them as 4 output receivers. We do have another output 16 receiver, and it is configured differently. Okay, so we have already gone ahead and booted up our controller, and our controller is ready to roll. So let's go ahead and turn off this screen and go into our xLights. Now, what we're going to do is click Add Ethernet. In this particular case, I am using xLights 2025-09. Your version may differ slightly depending upon your point at which you're viewing this. I'll just put a name. If you have multiple controllers, it's often good to put a particular name where that's relative to you. It might have left yard mega tree, for example, right? Now, it's important to understand I'm not setting up the receiver. I am setting up the controller. Now, the controller is this right here. And so I am setting up this controller into xLights. All right, so the next thing I need to do is select the vendor. It is HolidayPix, and this particular model is a version 2. We're going to go ahead and take the defaults here, and I am actually, in this particular case, going to use universe per string. That's not efficient, but is simpler for our setup. You can choose to use it or not use it. All right, the next thing I'm going to do is enter the IP address. Now, if you don't know how to set up the IP address or get any of the networking that precedes this process, please see our other videos specifically on the HolidayPix Pro and how to set it up with a network address. Now, what we're going to do is go ahead and make sure that we can then access this. You can go down here to the open button and then open it. And I've gone ahead and opened it, and you can see this particular case, I have it directly connected to my computer, and its address is the 10.10.10.10. Again, remember, this is not the receiver. This is the controller. Now, let's go ahead and look at the configuration of our controller. Now, if we look, we'll see that we have long range on output ports 1 through 16. We do not have a second board, and we have 16 outputs for SPI. Okay, so let's go ahead and go in here and look at that again. So here we go. We have the SPI board on the bottom and the long range here, and these are our ports. All right, so now what we're going to do is set up a few props in various different configurations using the visualizer. Now, I am kind of skipping the steps because we actually normally want to do a layout first. We want to make sure that all of our props are in xLights in the layout first. You can, of course, create a controller, then the layout. But these props all absolutely must, without any exception, always match the real world. So, for example, let's say you have a house outline. And if your strings of pixels are really 72, your string should represent 72 exact pixels. If you have a particular prop that requires a model, the model must represent and be exactly as the design is made. So I'll give you an example. If your singing tree was built in two parts, so let's say instead of one string you use two strings, you would need to define that string. And let's say you used an output for the first one, and you did 1 through 150, and then you started on 151 for the second string. You need to configure that. Now, we don't need to configure the controller or the channels at this time because that's going to be auto-configured for us. We don't need to worry about these start channels or anything like that. xLights will take care of all that. Now, it's also important to understand sometimes when you make a change in xLights, make sure that you hit the save button. It will sometimes, even if you press enter, it may not fully recognize that. All right. So at this point, we will assume that you have properly set up your models, and those models absolutely represent what you have physically constructed and attached to the receiver. Okay, so let's go back to controllers. And what we're going to do is click on our controller, and this is the HinkSpeech Pro, and we're going to click Visualize. Now, the visualizer is basically a drag and drop system that allows us to put props onto receivers. Now, a little bit of background that helps understand what you're looking at. So the first thing we need to do is make a connection between what you're seeing here on the left, and you can see that we see 48 ports plus a serial port. The serial port is the extra jack that normally is not used. And what we have here is you'll see that there are little lines off to the left, and they're grouped in blocks of 4. Now, that may not necessarily apply as much to SPI outputs for the controller directly, but for long range, it completely makes sense. So you'll see port 1, 2, 3, 4, and then if we go down, you'll see that it goes all the way through 16. It has blocks for each one. So let's look back again at our physical box. This is 1 through 16. This is the board that is long range 1 through 16. It is plugged into this back ribbon cable. And if you look very closely, you can see up here it says 1 through 16, 17 through 32, 33 through 48. So that means these bottom connections are 33 through 48. We don't have a middle board. And then we have this 1 through 16. Now, that block that you just saw was 4 ports. This is ports 1, 2, 3, 4. This is 5, 6, 7, 8, and so on. They go from left to right. Now I'm going to refer to this as jack 1, 2, 3, 4. So let's go back and look at that relevance in xLights. This is jack 1, this is jack 2, this is jack 3, and this is jack 4. So why are they like this? This is because we have 4 pairs of wires that exist inside of each Cat5 cable coming from a long range. So that means that there's 4 ports in each one of these. Now, this thing goes out to the receiver. So let's go ahead and flip back on our camera here. And This means that each one of these receivers gets a pair of wires. And how they are physically arranged is that they are linked as 1 links with 5, which links with 9, which links with 13. So the data is actually going down the line and dropping off at each port. So that pair of cables does not exist solely for this one single receiver. Each receiver is using 4 pairs of wires. So pair 1, 2, 3, and 4. Okay. Now that may be a little complex, but it'll maybe make sense as we move along. Okay. So over here, we're going to go up, and what we're going to do is we're going to put some props. So let's start off something simple. Let's go ahead and put on output 2. So I'm going to drag this over to pixel port 2. And I just put this on. This is not set up correctly at this point. This, at this point, thinks it's directly connected to the controller. So let's show you an example of that. Remember how we showed you on this particular controller, 48 through 32 or 33 were the direct SPI connections. These right down here. Okay, so let's pretend like we're going to go ahead and put a megatree with 16 strings on that. If we drag that to here, you can see string 1, string 2, and see how it's put all 16 strings on there? Those pixels are now mapped out to this bottom board. Now, what we'll note there is that you'll see in a second, these do not have a block around them. There's not a different color with a number, and we'll see that in just a second. So I'm going to come up here to this output, which is long range. I'm going to right click on it, and I'm going to say Smart Remote. Now, at the beginning, I indicated that I had not set up this receiver. It comes from the factory by default with receiver address 0. Now remember, it is key to understand for this particular long range board, this board has 4 output receivers. It does not act as a 16. So when you go down here and look at the type, you may be tempted to select ThinkSpeak 16. That's ThinkSpeak 16 version 1, not the version 2. Okay, so we're going to go ahead and say Smart Remote 0. Guess what it does? It puts these pixels into a block. This block in blue or in green is indicating we're on receiver 0 or Smart Remote 0. And by the way, you may see references to A, B, or C, or so on. Some receiver models come with those letters, some come with numbers, and xLights sometimes will go back and forth. So anytime you see 0, just assume it's A. Anytime you see B, it would probably normally be 1. Okay, so why did I put this here? Well, this is because our seed pixels are on output 2. And I just named it output 2 for easy reference. And let's go ahead and now put on our output 9. So I'm going to just drag this over here. So if this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm actually going to put it up here. But see, it put it in the wrong spot. We need it to be in a remote. And it is not going to be on 0, not on 1, but on 2. And this will become clear in just a second. So what we have done here is we have receiver 0. So this is output cable 1, 2, 3, 4. And remember, I said that each cable applies to all of the outputs on one receiver. So this Cat5 cable is 1, 2, 3, 4. All right, so let's go back to xLights here. And that means that I've put this onto output 2, which is correct. And then we have receiver 1. Now, you'll notice that it put in a block, even though there's nothing in there. This is output 5, 6, 7, 8. And then we start again at the top. 9, 10, 11, 12. And again, remember that when we have our receiver, that this receiver is all four output receivers connected together. So this is 0, 1, 2, 3. So A is 0, D is 3, because we start at 0. Okay, so back to xLights here. Now we have our pixels all mapped out. So let's go ahead and close this. There is not a save button here. A few other things to note in here. First is you can check this, and this should be checked by default, hide models associated with other assigned to other controllers. If you have multiple controllers, you can then, of course, make it so that you're not seeing those models here. These are the things that are not mapped. Now, also, on the left, you will see a pixel count. Now, we don't have any pixels daisy-chained or multiple models per output, but we'll test that in just a moment. So you can see that it's added up 50, 70 to 0 and 0. Now, why this matters is in a smart receiver, it will vary based upon your specific controller CPU. And we will show you how that we can overload these outputs, and you'll see any errors that might appear in your configuration if there are errors down here at the bottom. Okay, so no save button, you just close that. Now the next step here is to upload our outputs. In this particular case, I am using universe per string. That's not normal, but you would not normally see this message. I'm going to go ahead and hit no. We're going to upload that into the controller. Now, what's happening in the background is our controller is being configured by xLights. xLights logged into the controller, configured all the options, and uploaded the configuration into the controller. So this controller, let's go ahead and just refresh our connection. Now, it also reboots the controller, so there is a short period of time when the controller is rebooting. Now, while we're talking about the process of the controller rebooting, it's important to understand that when you reboot your controller, that is the point that the configuration is sent down to the receiver. So, go ahead and take this out of test mode. And let's see what we got. It's not yet configured. So, your receiver must be connected, not only powered up, but also connected with the network connection when your controller boots up. You may see a message on the screen of your HinkSpix that says config LR. That is the point at which it's sending the data down to the receiver to tell the receiver, hey, you are a specific configuration. So let's go ahead and just reboot that and put this in here. Okay, it does actually look configured. So let's see here. We see that these are active right here, A, B, C, D, and it may be a little hard to see with the brightness here. You might be able to see that these are periodically flashing. So a few notes about the LEDs. So in this far right corner, you'll see Cat 5, and then it has 1, 2, 3, 4. This is the pairs of wires coming down this cable. So these each correspond with 4 of the pairs of wires. And so you'll see these briefly flash, and you'll also see these change in how fast they're flashing as we start sending data down the line. You'll also see that you're active. This means they're programmed. You'll also see down here that there's a red light that indicates that your fuses are not tripped. And then over on the right, of course, we've got a power light that indicates that the receiver is powered up. All right, now, there are several ways to test this configuration. You may be tempted to first go into xLights. Let's first show you how to test lights from the receiver. Now, we do have a test mode that is built into the receiver directly that we can invoke. But in this particular case, we are going to test from the controller, from the HinkSpix, to the receiver. So we'll go up to test outputs, and we have various different options. We can do universe by string, but in this particular case, we are going to do long range expansion ports. And now we got all these ports. Which ones are we doing? So let's go back and look in our xLights for a clue as to which ones we're testing. Now, This is port 1. So if we turn on port 1, we're actually going to turn on output 9. So if we test out port 2, we're going to be testing output 2. Okay, so again, let's go back to our Hinks picks. And so we want to test output port 1, which is going to be 9. We'll check a box here, and we'll just say blink blue. All right, now we have port 2 on, and we are going to blink blue. Now we can see that our seed pixels here, let me flip that camera on here. You can see that the seed pixels here, reminder, these are hooked up to output 2, are now flashing. So if we come over to xLights and we look at that, we can see pixel port 2, output 2. Remember, seed pixels are hooked up to output 2, are flashing blue. Now, what if we want to output 9? Output 9 is on port 1. So let's come back into xLights here and or into the controller and uncheck that and check off port 1, blink blue. Oh, did I get the wrong one? I think I may have. Yep, nope, port 1. Let's go back in here. Port 1, blink blue. And here we can see we have cable 9 output, and we have blinking blue LEDs on that particular port. Okay, so that means everything is working well at our hardware level, at our controller level. And whenever you're experiencing unusual problems, move down a level. So if you're testing using a sequence, move into xLights test mode, which is what we'll do in a second. If you don't have anything working in xLights test mode, move down into the controller and use the test mode in the controller. Okay, so I'm going to go ahead and clear all ports, and let's go ahead and test in xLights. So let's close this out. And what we're going to do now is go over to Tools, Test, and now we have a whole bunch of options up here. Now, let me go through each one of these. So outputs allows you to literally test each individual controller. So you can see this is rolled up to this specific controller with its IP address. And then what we have is the protocol, the universe, and the channel count in DMX. So the left number in brackets is DMX addresses, and the right is the xLights internal addressing. Now, you could say, okay, well, we'll just turn on everything in the controller. But normally what we're going to do is we're going to do that in models over here. Model groups, we don't have any groups. You could test groups of props you put into models. Now, what we are going to do is we're going to come over here to models, and we're going to test the specific ones we've configured. Now, remember, we did set up that megatree on the outputs of the main controller. That's not what we're concerned about here. But we're also going to test the outputs of the seed pixel and the node pixels. So what we're going to do is come over here on the right. We're going to say RGB cycle for this. Now, we could do just background intensity. And let me go ahead and check this box off. And then we are going to do a test that way. So let me turn on the camera. So I am now going to manipulate the slider. And we can move the output level up and down. And that's just using the background function. Okay, let me go ahead and turn that off. Okay, so let's go ahead and come over here to the RGB cycle. Now this is very helpful when we're testing outputs of a output, and we want to kind of see if there's activity really occurring. This also sends a lot of data, and we can even actually do a red, green, blue, which is really what ABC is. Red, green, blue, all means white, and none means black. So I've gone ahead and done that. So let me go ahead and turn on the camera so you can see that. And right now I am testing only the seed pixels. Let me go ahead and put a check mark in the output 9. Now you can see that the other nodes are working. And I can change the speed by using that speed slider. So we can change how fast this changes. And let me go ahead and turn this off so you can see what I've been doing. So again, I turn these on, and to have red, green, blue, all, I am in the models and I am on the RGB cycle. And then I'm just moving this slider at the bottom to change how fast. So usually pretty far over to the right is the way generally I will test that. So let's look at what we have now. So here are the actual lights flashing. And of course, as you can see, they're all working. So if I come over here and I go into the test button, I can see now that it shows that it is configured. In other words, it has a configuration. Remember, it said no config last time. Now it is configured. Now, also, a few things to note here. Look on the left. See how you can see these rapidly flashing? That indicates that you're receiving data across those. See how they're flickering? That's a good indication that all 4 pairs of wires, we are sending down data. Also, note that you only see the A and C, which is 0 and 2 receivers with green lights. Note that the 1 and 1 and 3 are not lit up. I know that it may be a little hard to see this. It looks like they're kind of, but A is lit up, C is lit up, B is not, and D is not. Why? Well, again, look back here. Let's go back into our visualizer. We only have these 2 particular ports set up. So we do not have all of them set up. So this is A, B, C. So we have one on A, which is again 0, and we have one on C, which is 2. So again, look back at this. You will see it there? This is lit up and this is lit up. So that's telling you, hey, you only have those specific receivers configured on those pairs. All right, so let's go back and look a little more complex setup. So let's go ahead and do something that might be typically done. Let's say that you have a house outline and you have multiple strings stringed together. No problem. What you can do is simply just I'll drag them over here to the right first. I'm just going to drag this out here, and I'm going to drag it on top of this existing one. So we have output 9 going first, then 2. If we want to reverse that, we can just drag that and flip that around. What's happening is data is coming out of port 2. It's going to this first receiver, which again, this is output 2. And it's going to this second one, output 2, 9, which is really not output 9, of course, at this point, but they are daisy chained together. How do we know that? Because they are within this single block of green, which is on receiver 0. All right. So let's go ahead. Actually, we'll go ahead and leave that. Go ahead and leave that there. And let's show you the singing Christmas tree. Now, singing Christmas tree is 2 strings. What happens if we, let's say, put it up here, and let's say we want it on outputs 5 and 6. What we can do is come over here, say, there. So remember, 1, 2, 3, 4, 5, 6, 7, 8. Now, what's happening here is that the xLights is saying, hey, this model, it's got 2 outputs. It told us even before that. It says how many strings. Got 2 strings. There you go. It needs to put them on 2 different stringed outputs. So it's simply just daisy chained. It should say daisy chain because this would be a daisy chain, but put them on the first output, which would be output number 5, then output number 6. Okay, now that's easy enough. But let's go to something a little more complex. This matrix has 12 strings, and let's just drag it in here. And again, remember it comes in as an SPI. That's not long range. Let's say we want to start this on 12. We want to use 12 through 16 outputs. So we go in here and we say, okay, you're 1. Oh, but now it's thinking, hey, I've got multiple receivers. I don't. I'm going to then right-click on that, say set remote, smart remote, and then I'm going to say cascade down port and make sure that we have HinksPix 4. And we're going to set up how many cascaded remotes. So we're going to set up 3 cascaded remotes. So what we have done here is we've told, and actually here, for simplicity, we'll take this out for ease of viewing. We're not using 1, 2, 3, 4. This is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's all 12 of our outputs. And remember, what I needed to do is first set that as to a specific remote, in this case 1. Then I also needed to say, make sure it said 4, because this is, again, a 4-4 receiver. I need to make sure we say cascade down port. And then we had to tell it how many cascades down. What it's telling xLights, hey, don't try to go this way vertically, go horizontally. Use up this one, then use up this one, then use up this one. And that's how we get them to span across these outputs. Now, I'm going to put something back that showed up just a second ago. Let's go ahead and exceed the limits of the controller. I'm just going to drag this singing Christmas tree, and I'm going to put it into outputs 1 and 2. Now, you'll notice over here, we have exceeded the limit of pixels. xLights knows, because it is a version 1 or 2 controller, CPU, it can output only 680 pixels per port. So when you add up 150 plus a 200, that equals 750 pixels. That's too many pixels to be output down this particular stream of data. So in this particular configuration, we are not able to put these props in there. And it tells you this, again, because we have a 750 and it's red in color. Normally, if it's okay, it would be black. It also has gone down here and told you port 1, 750 allocated, but it only can handle 680. Now, if we had a version 3 CPU, this would allow us to do 1024, and this would not be an issue. So this is not a limitation of the receiver, it's a limitation of the controller CPU and the speed at which that CPU runs. So let's take out our Christmas tree, and let's put in something that could work. So let's go ahead and put our seed pixels back here and right here. So you can see that we have no problem putting in this combination, because this is 650, this is 672, so that's below our 680 pixel limit. And that all works. Now, this concludes the setup instructions for this. Of course, if you ever have additional issues or questions, you can always reach out to us at HolidayCoro.com/contact us, and we'll be happy to help you with your configuration. Please also see our other videos on configuration of the controller and other topics, including layouts and models, how you install those, and how you just generally operate through xLights.